So types of linked list. So basically there are four types of linked list. The first one is the singly linked list. The second one is the doubly linked list. And the third one is the circular linked list. And the fourth one is the doubly circular linked list. So when I have said that there are four type of linked list, then it does not mean that there are strictly four types of linked list, because there are on the basic level there are four type of linked list, but you can create on an advanced level, you can create more than these linked lists. What I am trying to say that these are basic level of linked list, but while implementing this, let me just write it. While implementing these, you can so on the ground level there are four type of linked lists that are mentioned here. But while implementing these linked lists, you can modify them, you can do your own changes in them on the code level, and by doing these changes, you can create your own type of linked list. So now we will study these basic four level of linked list, these ground level, these basic level of four linked list. So let us start with the singly linked list. In this session we will see introduction of these four linked lists, and in the upcoming session we will study their properties and code and their implementation. So singly linked list. So this is, I can say, a primarily linked list, because whenever someone is talking about linked list, and if someone has only mentioned linked list, if someone has only mentioned linked list, then it means that he is talking about the singly linked list. So I can say that this is a primarily or the most important linked list. So this is the linked list which we have studied in the previous session. That is that is the singly linked list has node which has two boxes. The first one is to store the value, and the second one is to store the address of successor, or I can say address of its next node. So since this is a value, so this is the integer type variable. If it's an integer value, then it's an integer variable. If it's the character type value, then it's a char variable. If it's the string type value, then I can say it's a string variable. So if I will consider this value as the integer value, then I can say that it is a int type variable, and this is the respective pointer to store the address of the next node. So if I will give you example of the singly linked list, if the linked list contain 3, 7, 8 as its member, then I can say that in first node I will have its first member 3, and the second node I will have the second member 7, and in the third node I have the third member 8. Let's say the address, we know that this complete box, this complete one is the node, this complete one is the second node, this is the first node, and this complete one is the third node. So now let's say the address of first node is 100, the address of second node is 120, and the address of third node is 140. Now in the first node we know that the first box store the value which is 3, and the second box store the address which is 120. Now with the help of 120 we can reach to the second box. We have made the link to the second box. Now in the second node, in the first part we will store the value which is 7, and in the another part we will store the address of the next node which is 140. Now here we know that after 8 there is no other member, so here I will store null. So this is an example of a singly linked list. And now we will also made a pointer variable named as head. This is a pointer variable. Now this pointer variable, this head, will store the address of the first node which is 100. So it stores the address 100, and with this 100 it points toward the first element. So when in the next session, in the third session, we will see the insertion, we will see the creation and traversal of linked list. Then we will see that how this head works actually. For now, just understand that this is a pointer variable which stores the address of this first node which is 100. Now in the singly linked list, in I can say singly linked list, only forward sequential movement is possible. Now why only forward sequential movement is possible? Because you can see that in the here we have the address 120, so I can go in the forward direction. Now here when I will reach here I have the address 140, so I can go in this forward direction. But now let's say if you are at this position, then from this position you can't go here, because here you don't have address of this. But if you are for example, if you are here at the second element, then from this second element, since there is the address 140, so by knowing this address you can go in this forward direction. But here address 100 is not there, so you can't go backward. So therefore I said only forward sequential movement is possible, because only the address of forward member is stored here. So now I hope that this is clear to you. So now let us move on to the second list, which is doubly linked list. So now doubly linked list. Now in doubly linked list, each node has 3 parts. Each node has 3 parts. That is, in each node I will make 3 parts, and this middle part will store the value, the data member that it need to be stored. This part as usual will store the address of next node, and this part now will store the address of previous node. So this part is new, this part is added in the previous node, as we have seen, because previously in the singly linked list there were 2 parts, which is the value and address of next node. Now in doubly linked list we have added the one extra part, which is address of previous node. So if I will give you an example of that 378, that was 378. So this is, let's say 378. So it's 3, it's 7, it's 8. The address is 100. Here the address was 140. Here the address, let us take 120. Now again here I will have head, and head will again store this address which is 100. Now here the next node address is, we can say it is 140. Again here the next node address is 180. Now again the address of next node, we know that after it there is no next node, so this address is null. Now here we need to store the address of previous node. Now the previous node of 8 is 7, so this address is 140, so I will store 140 here. Now here I will store the address of previous node. Its previous node is this, whose address is 100, so I will store 100 here. Now before 3 there is no node. Now don't say that this head is node. This head is not node. It is not node. I have told you that this is a pointer variable which store the address of this element of this first node. So this is not node. So before 3 there is no node. So here I will put null again. So now you can see that from here I can go in the forward direction. With the help of 100 I can go in the backward direction. With the help of this 180 stored address I can go towards 180. With the help of this 140 stored address I can go toward 140. So you can see that doubly linked lists are bidirectional because we go in any direction in the doubly linked list. So if I will talk about the code of doubly linked list, so if in the previous session you have not the code of singly linked list, because that code that we have studied for the linked list was for the singly linked list, because I have told you whenever we talk about linked list, then primarily it is singly linked list. So in that code, if I will talk about the struct part, if I will talk about struct part, then you can put int data here. You can put struct. Here I will talk about C. Here I will talk about C++. I will talk in both languages so that more students can understand. Struct node star next member. Struct node star previous pointer. So it's a previous. So now next is the pointer. So you must note that when I say int star a, then a is a pointer of type int. Now this next is a pointer of type struct node. So this next will store the address of struct node. Here in this case a used to store address of integer. If I have char star b, then b is a pointer which store the address of character. So next is a pointer which store the address of node. Previous is a pointer which store the address of node. And here we have described their name, which suggests us that next store the address of next node, and previous store the address of previous node. And if in C++, if I will show you my previous code, so this code was for the linked list. So here at this point we can make addition, and here in the parameter we can make addition. So if I will tell you the code basically, so I am again repeating that. So at this stage it is possible for you that this code is not understandable to you, are not able to get this code. So don't worry about it. In the lecture 3rd we will be creating and traversing the linked list. So at that point this code will be you will be able to understand these codes, and we will also implement them in the VS Code, so you will be able to understand them. So for now just note it down. In the class node I can just make public int data value, again node star pointer next node, node star pointer previous node, again a constructor int value, node star address 1, node star address to. Now again in the bracket, since there is some low space, so I am writing in only one line. Data value is equal to value. Then in the next line you will write next node is equal to address 1. Again in the next line we will write previous node is equal to address 2. So in this manner we can do our doubly linked list implementation for the node in C++ and in this manner in C language. So now I hope that doubly linked list is also clear to you, and as I have told you that don't worry about the code for now, worry about the code in the third session. So the next linked list that we want to study, that we need to study, is circular linked list. So circular linked list is nothing but variation of singly linked list. If I will give you example, previous example of singly linked list, so that was, let's say it is 3, let's say it is 7, let's say it is 8. Its address is hundreds, it's 120, it's 140. So here the address which we will have is 120. Here the address which we have 140. And in the previous case the address here used to be null. So we have seen that earlier the singly linked list was like that. Here we have the head pointer which store the address of first node, and we have noted that singly linked list was like in this way, and here we have null because it was not pointing towards anyone. But now since this is a circular linked list, so the structure of the linked list should be circular one. So here I will put the address of the first node so that it is pointing toward the first node. So now you can see that the structure is circular one, therefore it is called as a circular linked list. So if I will write the definition of circular linked list, then I can say that it is similar like singular linked list only in last node at place of null pointer we will put address of first node. Now I hope that the circular linked list is also clear to you. The code for its node will be same as singly linked list. The only difference will be in the implementation, which we will see in the code later on. So now let us focus on the fourth part, and the fourth part is it is doubly linked list. So I can say that doubly linked list is combo of, it is doubly circular linked list. So I can say that doubly circular linked list is combo of doubly linked list and circular linked list. So it is combo of doubly linked list and circular linked list, or I can say it is combination of doubly linked list and circular linked list. So it has property of both doubly linked list and circular linked list. That is if I will take an example, so let me just make a doubly linked list. It's 3, let's say it's 7, let's say it's 8. That this again I will take, let's say so let's say now take some new address. It's 1200, it's 1300, it's 1400. So now the address here that would be stored will be 1300. The address here would be 1400 of this next node, and the address here would be 1200. The address here would be of previous node, which is 1300. So this is what we know about the doubly linked list till now. But now if I want to make this doubly linked list as doubly circular linked list, then I need to make a circle like structure. So to make the circle like structure, we will do the same idea that we have done in the circular linked list. We need to just remove null. What I have just said is, in circular linked list, what we have done basically, let me just show you. So in circular linked list, at place of null, we have just put the address of the first node to make the circle like structure. So similar we need to done in the doubly circular linked list. So in doubly circular linked list, we used to have two null. The first null is here, the second null is here. So now at place of this null, I will put the address of the first node so that I can make it circular. So I will put here. And here in this address where we used to store the previous address, I will put the address of this last node so that I can make it circular from this side also. So the address of this is 1400. So I will just put 1400 here. So now you can see that the link is now made here like this. Now this is the doubly linked list. If I will write the definition for this is, so if I will write the definition for doubly circular linked list, then I can say that it is similar to doubly linked list. The only difference is that at place of null in last node, you will put the address of first node, and at place of null in first node, you will put the address, I will say address of last node. In this way, the concept of doubly circular linked list is finished. So these were the 4 type of basic linked lists that you need to know about. And as I have told you, when you will be master in implementing these linked lists, then you can do some your own modification in these linked lists and create your own type of linked list. But the thing that you need to understand from this lecture is these 4 basic type of linked list, because their understanding is important. Because if you will not know if you don't understand these linked lists, then you will not be able to do some modifications. So now here this session is completed. So see you in the next session, where we will be discussing creation and traversal of linked list with code, and we will implement its code in the VS Code and understand this concept